60 key. So in this video we discuss about how you are going to design the full adder using 2x1 Mux. So in previous we already know how to design a full adder. So full adder designing is a simple method. So when you are going to some complex some other interviews like that, they just don't stop with the full adder design. There may be little complex things. So then there may be a chance to ask design a full adder using 2x1 Mux. Then we have to know what is the block diagram. First we have to know the theory part, then it is easy to convert that theoretical part into the coding part. So first I give overview of the how you are going to design this full adder using 2x1 Mux, and I also give the code and its explanation and its test bench and how you are getting the waveform and how you are going to be the our block diagram like that. So for that first this video is maybe going to be little long, but it may be useful for you. So just spare some time for this video. So first, what is our aim? So full adder using 2x1 Mux. So how you are going to design means, so first we have to write the truth table for the full adder. So we are going to take the 3 inputs ABC and the sum and the carry. So all know for 3 inputs we get 8 combinations, and 3, 4, 5, 6 and 7. So our sum is like 0, carry 0, 1, 0, 1, 0, 0 carry with 1. So 1, 0, 0 carry with 1, 0 carry with 1. So 1 carry with 1. So it is our truth table. So what you are going to do means, so first we have to draw the K-map. So I think we all are familiar with K-map. So there are the 3 variables. So that's why you get 8 cells here. So what is the A, B, C? You can take combination like this. So 0, 0, 0, 1, 1, 1, 1, 0. So this is 0 and the 1. So what you are going to do? So just write 0, 1, 2, 3, 4, 5, 6 and then 7. I think you all are familiar with K-map. So if you don't know about K-maps, then you can simply comment I don't know about K-maps, can you please make it another video? Then I do separately about the K-map. So until then I think you are familiar with K-map. So that's why I going to this video. If I tell the K-maps also, this video is going to be so long. So that's why I don't enter into that concept. So just simply done the K-map for this. So what are the ones here? So just we have to represent the mean terms here. So what is the mean terms for 1? So for 2, so for 4 and then 6. So what you are going to do means, so let us consider the 2x1 Mux. So there for 2x1 Mux there is a 2 inputs and 1 output. So one select line. So for I consider the select line will be this A, because the select means you are going to do, so if the select line is equal to output means, so it is our output, Y is nothing but our output I take. So if the select line is going to be, so if the consider I0 and I1, if the select line is going to be 1, then our input will be I0. So if the select line is equal to 0, then our output will be I1. So like this we are going to assign the particular value by using this select line. So for better understanding, I consider these A values. So what I am going to do means, so I simply write A is for the select line. So for A equal to 0, so A equal to 0, what you are going to do? So I0 will be going to be select. So second box is going to be select. So how you are written means, so just simply see this properly. So the 1 is here and the 1 is here. So what is the BC values here? So 0, 0, 1, 0. So it is going to be like this. So what you are going to return means, so see 0, 0 means B bar, C bar, plus 1, 0 means, sorry it is okay, sorry, here you can see it is the 7 value is going to be 1. So the 1 is there. So 1. So the values here is BC. So what is this combination is nothing but B XOR C. XNOR C. Sorry, XNOR C. Means, so that's why so I0 will going to be this equation. So next consider the I means 0. If the select line is going to be 0 means A value is going to be 0. These line going to be select. So what is our K-map then? So the 1 is here and here. So you can consider only this this line only. So the values of BC is 0, 1 and 1, 0. So means B bar C plus B C bar. So it is nothing but B XOR C. So for I1 the values are going to be, so 1 minute I erase it and So now we are connect our 2x1 mux according to our thing. So this is our 2x1 mux. So the select line is going to be considered as A, means 0 or 1. So if I0 is equal to 1 means A value is going to be 1 means then this line going to be select. So this line equation will be but A XNOR C. We already done the K map. So for select line is going to be I1 means that is going to be B XOR C. So what you are going to do? So it is our I1. So for I1 we write the B XOR C. So what is our I0? So I0 is our XNOR. So XNOR means XOR NOT inversion is nothing but our XNOR. So just what we are going to do, just simply connect the NOT gate here. So we are simply going to connect the NOT gate here. So it is, you can get the sum. So this is our sum K map. So that's why you get the sum here. So for carry also same process you are going to do. So again you can take the K map for carry also. So A, B, C. For carry we are getting the values for, see in the truth table for 3, 5, 6, 7. So means 3, 5, 6, 7. These values you are going to get the ones here, min terms. So how you are going to represent? Again A is equal to 0 and A is equal to 1. So again consider the 2x1 mux. So you are going to select the A is our select line. So if A is equal to 0, so if A is equal to 0, so this I1 is going to be activated. So what is our I1? So we are going to, if A1 is equal to 0, so means this line. So this line means 0 is nothing but 1, 1. So here the values are 0, 0, 0, 1, 1, 1 and 1, 0. So here B, 1, 1 means, so B, BC. So BC is our AND gate. So we are simply give BC and AND gate here. So if the select line is equal to 0 means we are going to get the output as I1 means BC. So if the select line is A is equal to 1, so you get I0. So I0 is nothing but, so this means this second line, so second row. So what you are going to do means, so here we can see how you are going to combine the K map. So if it is like this, so how you first you have to combine these two, and for this you can combine these two. So why you don't combine these two means in vertical means, so it is, we are only consider this horizontal only, so not vertical and like that. So that's why only you can combine like this. So first we have to find the K map for this, and for second we have to combine and we can add the both. So for that we can simply write, again I draw the K map here. So 1, 1, 1. So for that we can see, so 0, 0, 0, 1, 1, 1, 1, 0. So for the both combination we get the value as C, plus for this we get the value as B. So B plus C is nothing but OR gate. So we are going to connect the OR gate here, BC. So same values. So it is our I0 and final output is our carry. So remember these two block diagrams. So what are the block diagram I draw here and what are the block diagram I draw here. So you have to just remember these two. So these are, by using these two only we are going to write the code. So if you understand these two concepts, so it is very easy to write the code. So for that purpose I simply draw the again the two blocks here. So 2x1 mux. So we are getting the carry here. So here also there is a 2x1 mux. So here we getting the sum carry. Here we getting sum. Here we getting the carry. So it is our output. So here also select line will be A. Here also select line will be A. For sum what is going to do means, so for it is I0 and I1. So for I1 we are going to give the XOR. So the BC will be the input. So here going to the NOT gate and we give to the I0. So here also I0 and I1. So for I1 we are going to give the AND gate. So for the same BC values we are going to give the OR gate here for I0. So this is the concept we are going to do. So for simply purpose we are going to say that this wire may be the G1. So this wire is going to be G2. So this wire is going to be G3. So these wires are going to be just connect the port output of one gate to the input to the mux. So no need to mention it is input or output. We just use it for the wire purpose. So I already say what is the use of wire, what is the use of range. If you don't watch, so go to that videos and there is a detailed explanation about the types, data types here in the Verilog. So until then it is about we are consider these as wires. So there is only the connection of one output to the another input. So that is the purpose of wire. So no need to store any value. So this is the theoretical part we are going to done. So next by using these two block diagrams we are going to design the full ladder. So just see. So first you have to write the mux code. So why you are going to write the mux code? By using these mux you are going to design the full adder. So that's why you have to write first the mux design code. So how you are going to design? So already I have to done this mux, how you done the mux and demux and all the things in previous videos. So this is a complex than those videos, means those designs. So first you have to write the mux. So module followed by module name here. So inputs, what are the inputs for the mux? So they are the two inputs, I0 and I1, and the select line S, and the output will be the Y. So what you are going to do means, if at a time there is a one input is going to be select for the output according to your select line. So what you are going to do, so by using assign keyword, what you are going to assign, so for Y value, so output you are going to assign. If the select line, it is a conditional operator, means if the select line is equal to true, means question mark is represent as true. So if it is true, I0 value is going to be S. If the select line is equal to 1, so output will be the I0. It means like this. So if the select line not equal to, means not true, means S equal to 0. So in a Verilog not true means that it is equal to the logic 0. So if it is a true, so it is equal to the logic 1. So output Y is going to be I1. So it is our I1. So like this we can represent and end with semicolon and followed by end module. It is our mux design code. So we have to instance these mux code in our main code. So what is our main purpose of full adder? So designing a full adder by using mux. So you have to instance these mux in this full adder. So how you are going to write means, so it is our main code. So for module followed by module name and input. What are the inputs for the full adder? ABC, and the outputs are sum and carry. We already know about that. So for full adder the inputs are the ABC and the sum and the carry are the outputs. We all know about that. So for here you can see, sorry, I can consider the 4 wires. So it no need to be double G4. So 3 wires are going to be sufficient. So if you write also nothing changes, but there is a memory allocation, so no need to write. So you can simply write wire W1 comma W2 comma W3 semicolon. No need to write the W4. So what you are going to do means, so first we are going to write the XOR gate here. So giving XOR gate. So XOR. So I already say that primitives. So in Verilog there is a primitive, means inbuilt gates like that. So XOR it perform the XOR operation of the 2 inputs or 3 inputs. What you are going to do. So how you are going to write means, so first you have to write the primitive. So whatever gate that you have to write that primitive name and followed by output, and those are followed by inputs. So it may be single input or multiple inputs or 2 or 3 more inputs. So depending upon the primitives. So you can simply write the XOR followed by output. So I simply kept the output of XOR gate in the WG1. So then after that WG1 is going to be connected to the. So first I am going to connect these BC and output will be WG1. Then again the mux input is going to be connect these WG1 with this mux. So like that I am going to done. So first you have to write the output as WG1 and what are the inputs BC. So now you are going to write the mux. So how you are going to connect? So mux, you have to instance this mux. So you have to instance this mux in this full adder code. So how you are going to instance? So instance module name. So what you are going to instance, that module name is going to written here and followed by instance name and followed by port connection. So how you are connect these ports? So just see here block diagram. So I0 is going to be converted to the NOT gate of WG1. In Verilog we represent NOT gate with this symbol. So like this is the symbol. So that's why I simply represent like this and comma. So second input is our WG1. So I am simply say that this is the WG1. So bitwise not operator W1 comma, and what is our select line is going to be here. So I say that the select line will be A and followed by sum. So it is our output. So you can write this order in the same this order. So I0 is going to be our invert of WG1. So I1 is going to be this of WG1. So select line is going to be 1. Y is going to be sum. So according to our design code in the module. So what are the mux design code? The order is same as we can written in this code. So if you write means WG1 comma double and ampersand sum comma, if you write in different manner, it consider in different manner. So your output is getting to be error. So first you have to know the port connection. So there is a two types of port connection. I already done the how you connect the ports in previous video. So if you don't watch how to connect the ports means, it is very difficult in upcoming videos when you are going to watch. So first you have to know about the port connection, then only you get the proper output according to your inputs. So you have to going to connect like this. So next going to the carry. So until then some part is completed. So next we have to go to the carry part. So what you are going to do? So BC and followed by WG2 is your output. So what you are write and primitive. So you have to write the primitive followed by output. So I consider the output as WG2. So WG2 is our nothing is input not output. So that's why I mention it as a Y data type here. So if you don't write this Y data type means it simply take as an error. So don't forget to write this as a Y data type. So WG1 comma here you can write WG2. What are the inputs BC? So again we can use OR gate. So OR gate, we have to simply write OR. What is our output? W3 comma B comma C. So now you are going to connect these to the mux. So you simply write the module name of the mux. So here I write the module name as mux. If you write any different name, mux underscore 2, you can write, means you simply write mux underscore 2 here. So what is the module name you written here? Simply write the module name here and followed by instance name, and you have to connect the ports. How you are going to connect? So I0 is going to be connect. So see, I0 is going to be connect to W3. So W3. So next see, I1 is going to be connect W2. So you can simply write W2. So according to the order what you are write in the module in the mux code, you simply follow that order. So next our select line will be A and output will be our carry. So followed by AND module. So it is our design code. So if you have any doubts, still this is design code, you can comment it. I can make separate video about the particular design code itself. So just look into the test bench. It is very similar about the full adder design code. So nothing changed here. So just module name and instance name is going to be changed. So module followed by module name, and what are the inputs you can simply written in the reg data type. So outputs are simply written in the y data type. So when you are going to use the initial block, so what are the variables you are going to use in the initial block, that variables should be in the reg data type. So that's why you can simply write the inputs in the reg. So you have to make it down. So why you are going to write as reg only as the inputs, so why not y means you can write wire also if you don't use initial block. So whenever the always block and initial block are going to be used, so you can must and should remember what are the variables you are used in these two blocks. So that should be a reg data type. So it is one of the rules, so don't forget about that. So don't go blindly inputs are reg. So know the reason. This is the proper reason we are going to know. So followed by here you can write the design code module name. So design code module name followed by instance name. You can write any name. You can write your name also. DUT means design under test. You can simply make any name also. So port connection, you all know about the port connection, and initial begin. In this initial begin, you are going to give the different input combinations. So input combinations are going to be given in this initial block. I give different combinations of ABC values and give some delay, and again I give some ABC values and again I give delay. So finally I want to stop the simulation. So that's why using the keyword to stop the simulation. For stopping the simulation, you simply use the finish keyword. So this begin, what are the initial begin is going to be end here, and module is end with end module. So for that combination I get the output waveform here. So just look into that. So ABC. So we all know about A equal to 0, B equal to 1, C equal to 1. So what is our sum? So 0, sum is our 0 and carry is equal to 1. So our output is going to be correct. We can cross check like this. So sum is equal to 0 and carry is equal to 1. So your value is correct, is going to be correct. Sorry. So it is our final block diagram. So how it is represented means it is our schematic diagram. So it is our schematic diagram. So see, there is a 2 by 1 mux. So I simply say before. So for I1, so what is our I1 input is going to be our XOR. So here you can see XOR. So this XOR is going to be NOT, and it will be the X0 is going to be our I0. So select line is going to be A. So see, this line is going to be R0. So see, this is the A. So our select line is going to be A. So for second one also you can see it is our A. Select line is going to be A. So for I0, our here you can see it is our OR gate. So whatever the block diagram we can so it is our AND gate. So whatever the block diagram you written before, so it is our schematic. So you can cross check and you can try to understand the schematic. It is very useful while you are going to design the hardware implementation. So it is very simple to understand according to our design before. So these two blocks are going to be represented here. You can simply observe those here. So if you have any doubts, you can comment it. Until then, bye. Thank you so much for watching this.